That's it. So, part 22, and yeah. Okay, so equation of the circle C1 is 4x squared plus 24x plus 4y squared minus 16y plus 43 equals 0. And the equation of circle C2 is that. Sketch a diagram of these circles on the axis below. So, first I'm going to solve this equation. So we know that the first one, this, I can divide it by 4 to get x squared plus 6x plus y squared minus 4y plus 43 over 4 equals 0. So this is x plus 3 squared minus 9 plus y minus 2 squared minus 4 plus 43 over 4 equals 0. So then we have x plus 3 squared plus y minus 2 squared equals 9 plus 4 minus 43 over 4. So this is 13, which multiplied by 4 is 52 minus 43 over 4. So 52 minus 43 is 9 over 4, which is 3 over 2 squared. So that's the first circle. Just move that there. So from this, we know that as a centre minus 3, 2, so somewhere about there. And its radius is 1.5, so it's not going to touch any of the outer areas. So now let's do the next circle. So we can divide that by 4 to get x squared minus 10x plus y squared minus 2y plus 79 over 4. And we know this equals 0. I'm not sure if you can see that, but it equals 0. So we then have x minus 5 squared plus minus 25 plus y minus 1 squared minus 1 plus 79 over 4 equals 0. So we then have 26 times 4 is 52, 104 plus 79 over 4. So 104 plus 79, 9 plus 4 is 3, 1, that's 8, 183 over 4. Is that right? Oh no, minus, we need to minus it. 104 minus 79, well, that's just going to be, we need to have a 1, we need to have a 24, and that's it, so plus, so a 25, right? 79 plus 25, so I'm a bit tired at the moment, so brain's going a bit slow. So 7 plus 8, 7 plus 2, that equals 9, plus 1, that equals 0, 104. Yes, so 25, so this equals x minus 5 squared plus y minus 1 squared equals 25 over 4, which is 5 over 2 squared. So we can now draw okay, wait, let me just like okay, so I can now draw this circle. So this has a centre of 5, 1, which is going to be below. But it's going to go through this because the radius is 5 halves, which is bigger than 1. So that's the sketch of the circle. So I'm just going to write C2, C1. So along with the lines which are tangent to both circles. So lines which are tangent to both circles is going to be that line, and then there's going to be this. Oh, that's awful. Oh, that's awful again. Why am I so bad at this? That line. And this line. Okay. So those are the lines which are tangent. So for each line, calculate the lengths of the line segment joining the tangent points. Okay, so this may be a little bit confusing at first. So what I'm actually going to do is I'm going to get rid of these two just to focus on these points. So there's a well-known proof, actually. Wait, let me draw these lines a bit better. Okay, so there's a well-known proof of how this works, but if you don't know, it's basically like this. You can actually draw a rectangle between these points. And how you do it is you go like this, and then this goes down to there. So now what you've got here is you've got a rectangle here. So we know that this length is 1.5. So therefore this length is 1.5. And then we just have this distance here between them. But what we need, but like it's also kind of down here. And we know this distance here is 2.5. This distance is 2.5. And therefore, we can draw this line between the radiuses as the third side. So now, we just need to find the distance between the centres of the circle, which is -3, 2, and 5, 1. So to find the distances, we're going to use Pythagoras' theorem. So we have 2 minus 1 squared, which is 1 squared, plus -3 minus 5 squared, which is plus 8 squared, I think. Which is 64 plus 1, which is root 65. So that's the distance there. So we have this, where we have root 65, and then 2.5 plus 1.5 is 3 plus 1, which is 4. So then to work out this side, this length here, which we need, what are we going to call this? I'm going to call this x. We know that x squared equals 65 minus 16, which is 65 minus 16. 5, 1, 15 minus 6 is 9. 5 minus 1 is 4. 49. So this equals 49, which means x equals 7. So that's the length of this tangent, these tangents here. And they're both symmetric, by the way. So 7. Then, to work out the length of the other tangents, what we have to do... Wait, let me just see. Let me just draw the tangents back on. Okay, I guess I have to keep those on. Alright. So, let me just draw them. These are also going to be equal in length. So, let me just see here. So we have this line here, connecting them. And then we have this here, connecting them, where the length between the, what are they called? I can't remember. The length between the centres is root 65, I believe. Yeah, this is root 65. I mean, this is 90, and that is 90. So, what we can do to work out that this length here is we can just work out this length here, which is 2.5. Oh yeah, this is 1.5. So then what we have then is just a simple trapezium, where we have root 65, 1.5, 2.5. We need to work out this length here. So we do that by doing 2.5 minus 1.5, which is just 1 root 65. And this length here I'm going to call R, equals 65 plus 1, which equals 65 plus 1? Yeah, it's equals 66. So R equals the square root of 66, I believe. Yeah. Alright, so